Hey there. Welcome to the Deep Dive.
Thanks for having me.
Today we're going deep with the Pragmatic Programmer, the classic guide.
Yeah. Been around for over 20 years, shaping devs.
Exactly. And we've got excerpts from the 20th anniversary edition. Trust me, it's packed with advice that, well, it never gets old.
It's amazing, isn't it, how relevant it still is?
Totally.
Yeah.
And it's not just about, churning out code. It's about the whole mindset, the philosophy, like how to be a truly effective programmer.
Absolutely.
So ready to get pragmatic.
Let's do it.
Let's dive right into Chapter 1, a pragmatic philosophy.
Sets the stage, right?
It does. Some powerful ideas about taking ownership.
Yeah.
Responsibility for your work, your career.
Big stuff.
Yeah. And, the first thing that grabbed me,
What's
the whole idea of a programmer, actually having agency.
It's easy to feel like a cog in the machine sometimes.
Especially when, like, deadlines are looming and the specs are constantly shifting.
Happens all the time.
But this book, it reminds us we have choices.
Yeah.
We can shape our work environment, our code.
We can.
It resonated with me because, I think a lot of us, especially starting out, feel stuck.
Stuck in situations we don't love.
Yeah, exactly. Messy code base, a project with, like, unclear goals. It's tempting to just, accept it. Part of the job.
All right, but
The authors, they urge us to take responsibility, make a change.
love that.
They use this analogy, remember? The frog slowly boiling
Oh, yeah.
in a pot. If you don't like the heat, jump out.
Don't get complacent.
Exactly. You have the power. You can make things better.
Absolutely.
We've all been in that boiling pot at some point.
Probably.
But sometimes it's hard to know, like, where to even start.
Yeah, good point.
So what are some practical steps we can take, to exercise that agency?
Well, they talk about, fixing broken windows.
Oh, yeah.
It's a great metaphor, right? You're addressing those small problems before they snowball.
Before they become huge.
Exactly. Like, messy code snippets. Inconsistencies in the documentation. Those little things that, well, everyone knows are wrong.
But nobody fixes.
Yeah.
It's like that saying, a stitch in time saves 9. Addressing those issues early on, you prevent major headaches later.
And it shows you're proactive. You care about quality.
Exactly. It's not just fixing things. It's also taking ownership of our mistakes.
We all make them.
We do.
Yeah.
But it's how we respond that matters.
Sure.
They emphasize offering solutions, not excuses.
Builds trust, respect within a team.
Big time. Taking responsibility for both, the good and the bad.
That's being a professional.
It is. It shows integrity. Helps us learn from our mistakes.
Absolutely.
And speaking of learning, the authors, they compare a programmer's knowledge base to a financial portfolio.
Interesting.
It is. You need to, like, invest regularly, diversify your skills, and keep learning. Stay ahead of the curve.
Keep those skills sharp.
They even suggest learning a new programming language every year. I know, it might sound ambitious, but
It makes sense, right?
it does. It exposes you to different ways of thinking, approaches to problem solving.
Cross-training for your brain.
Totally.
Yeah.
It's easy to get comfortable with what we know,
We all do.
but technology, it keeps evolving.
Always moving.
Learning new languages, even if we don't use them directly, makes us better programmers overall.
I agree with that.
It's not just about languages, right? They recommend reading a technical book every month, conferences, engaging with the community.
It's just staying curious.
Exactly. Continuously expanding that knowledge.
It never stops.
So we've got agency, we're fixing those broken windows, we're learning like crazy. What's next in this pragmatic philosophy?
Well, they introduced this concept of the stone soup and boiled frog.
Okay, stone soup, I remember that story from childhood. How does that apply to programming?
Well, it's about starting with a simple idea, and then through collaboration and communication, you gradually build it into something more substantial.
Like in the story, everyone contributes a little something.
Right, even if they think it's insignificant.
Right.
It's like a software project where everyone has something to offer.
Even if they don't feel like they're the star developer.
Exactly. And by communicating, sharing our knowledge, we create something amazing.
Together.
Yeah. They also talk about being a catalyst for change.
Oh, yeah.
That person who sees a problem, doesn't just complain, but actually takes the initiative.
Thickest is it.
That's the boiled frog in action, jumping out of a pot.
Love it. Making things better.
It's inspiring. We can all be those catalysts.
In our own work environments.
Absolutely.
It's about stepping up, taking ownership, not just for our own code, but for the success of the whole project.
Couldn't agree more.
Absolutely. Now, Chapter 2. It dives into some core design principles, starting with DRY. Don't repeat yourself.
Oh, a classic.
Right. This one seems like pretty self-explanatory. Don't copy and paste code all over the place.
Right, but they take it deeper. It's not just about duplicate code.
So it's about what?
Eliminating the duplication of knowledge,
Okay.
which can manifest in many ways. Think about documentation, data schemas, test cases, even communication within the team.
Interesting.
Yeah. If you find yourself explaining the same concept over and over, that's a sign. You need a single source of truth.
Makes sense. I can see how that applies even in my work. We have this one piece of business logic. It's scattered across multiple modules. It's a nightmare to maintain
Yeah, I bet.
and prone to errors.
Applying DRY there it would make a huge difference. Consolidating that logic into a single, well-defined module.
Improves readability, reduces errors, future changes are much easier.
It's all about making that system, easier to understand, easier to maintain.
Absolutely.
And speaking of making systems easier to understand, let's talk about orthogonality.
Orthogonality. Now there's a word you don't hear every day.
It sounds kind of mathematical. It does have roots in math, but in software, it means designing components that are independent, self-contained.
So, like, what does that mean?
Well, they use this classic analogy, a helicopter control stick.
Okay.
Imagine if pushing the stick forward to increase speed, it also caused the helicopter to, tilt sideways.
Oh,
That would be non-orthogonal design, a nightmare to control.
that makes sense. So you want each control to have a single, well-defined effect. So how does that translate into code?
Designing modules with clear interfaces and responsibilities.
Right.
Avoid creating those tangled messes where everything depends on everything else.
Right. Like those tightly coupled functions where changing one line can trigger a cascade of, unintended consequences.
Exactly. Orthogonality helps us avoid that. It's about minimizing side effects. Makes it easier to reason about the behavior of your code.
Makes your system more robust, adaptable.
Exactly.
This all sounds great, but let's be real. Sometimes we make decisions, we later regret. How do we build in flexibility for those inevitable changes?
That's where reversibility comes in. Avoiding those irreversible decisions. Requirements change, technologies evolve, the future, well, it's uncertain.
Yeah, for sure. So it's about avoiding those hard-coded dependencies.
Right, ones that lock you into a specific technology or a particular implementation. You want a system that's adaptable, easy to refactor.
So it's about designing for change,
Yeah.
anticipating those potential future needs,
Yeah.
building in options so you're not stuck down the line.
Exactly.
It makes a lot of sense, especially in today's, fast-paced tech world.
It does.
And sometimes those changes come in the form of entirely new features, new products. That's where they introduce the concepts of tracer bullets and prototyping.
Tracer bullet.
Sounds intense, right? Are we firing actual bullets at our code?
Not quite. It's a metaphor, right? You're building a thin slice of end-to-end functionality to get feedback quickly.
So instead of trying to build the complete system up front,
You build a skeletal structure, all the major components in place, but minimal implementation details.
I see. So this way you can get a feel for how the system, hangs together.
Right. Identify potential roadblocks early on. Get feedback before investing too much effort.
It's especially useful, I imagine, when requirements are fuzzy
Meh.
or you're working with a new technology.
Absolutely. You
Yeah.
learn by doing. You avoid those massive rewrites down the line.
And similar to tracer bullets, prototyping, another valuable tool for exploration.
Right.
How is prototyping different from tracer bullets?
Well, prototypes are more focused, I would say, on specific aspects of a system. You might build a prototype to test out a particular algorithm,
Okay.
evaluate a UI design, or explore a new technology.
So it's about isolating areas of uncertainty and experimenting to gain a deeper understanding before you commit to a final design.
Exactly. And the beauty of prototypes, they don't need to be perfect.
Oh, okay.
You can sacrifice completeness, even correctness. You're focusing on the specific aspect you're exploring.
It sounds like a playground for trying out ideas
It is.
and learning from those experiments.
Exactly. The value lies in the lessons learned,
Yeah.
not necessarily the code produced. It's about gaining insights that inform your final design.
Okay, so we've covered a lot of ground already.
We have
We've
it.
talked about pragmatic philosophy, design principles, and techniques for, navigating uncertainty. What's next?
Well, the authors, they dive into the often dreaded topic of estimating.
Oh boy.
Chapter 15 offers some practical strategies for making, well, more realistic estimates,
Yeah.
avoiding those all too common project delays.
Estimating is definitely a challenge. I've been in those situations where a project that was supposed to take, you know, a few weeks ends up dragging on for months.
It happens.
It's frustrating for everyone involved.
Absolutely. The book, it emphasizes using ranges instead of single point estimates,
Okay.
acknowledging that there's inherent uncertainty in software development. So instead of saying a task will take 5 days, you estimate a range, say 3 to 7 days.
It sets more realistic expectations, allows for some wiggle room.
Exactly. They also highlight the importance of understanding the units you're using. A 5-day estimate, it has a very different level of precision than a 5-week estimate.
Okay, yeah.
They even provide a table. It maps durations to appropriate units.
It's like a cheat sheet for estimating.
It is. Helps you choose units that reflect the level of accuracy you have.
At that point in the project.
Exactly.
Yeah.
And they stress the importance of asking someone who's done it before, tapping into the experience of others.
Makes sense. It's about leveraging that collective wisdom of the team.
Right. Of the wider programming community. It's amazing how much knowledge we can gain by simply asking for help.
Absolutely. Now, speaking of tools, the next chapter dives into those essential tools for a pragmatic programmer, starting with a somewhat surprising advocate,
What's that?
plain text.
Plain text.
I mean, isn't that a bit basic? You know, in today's world of all these fancy IDEs and visual tools.
You might be surprised.
So what are some of the advantages of using plain text?
Well, for one, it's incredibly durable.
Okay.
Plain text files can be read by virtually any computer system. Regardless of the operating system, the software applications, it's a truly universal format.
So you're not locked into any specific vendor
Yeah,
or technology.
exactly. Your data is future-proof.
I like it.
And because it's so simple, it's also highly portable.
Okay.
You can easily move plain text files between different systems, share them with others, process them with a wide range of tools.
So it's about maximizing interoperability and longevity for your data, for your code.
Exactly.
They also advocate for using plain text for configuration files, documentation, and even storing data.
How it simplifies things.
Yeah.
Parsing, version control, collaboration,
It sounds like embracing plain text can bring a lot of clarity
efficiency.
to your workflow.
It does.
And to further boost that productivity, they recommend mastering shell commands
Ah, yes.
and becoming fluent in your editor.
Shell games.
Sounds intriguing. What's so special about the shell?
The shell, the command line interface, it's powerful for interacting with your computer, automating tasks.
So it's not just about navigating folders, launching programs.
It's about using commands to manipulate files,
Yeah.
process data, even write scripts to automate those complex tasks.
It can be a massive time saver.
Huge.
I've always been a bit intimidated by the shell, but maybe it's time to give it another shot. What about editors? Any specific advice there?
Choose a powerful one. Become truly fluent in its use.
Sure.
Learn those keyboard shortcuts. Explore the advanced features. Customize it to fit your workflow.
Treat your editor as an extension of your mind,
Exactly.
a tool that empowers you to code quickly and efficiently.
They even suggest practicing those editing skills, like a musician practicing an instrument.
Oh, interesting.
The more fluent you become, the more effortlessly you can translate your ideas into code.
So it's about removing those friction points, letting your creativity flow.
Exactly.
And speaking of smooth workflows, they highlight the importance of version control.
Absolutely essential.
Version control, it's non-negotiable.
Yeah.
For any serious programmer, it's your safety net,
Yeah.
your time machine, and your collaboration tool.
Love that.
Like having an undo button for your entire project.
It is.
You can track changes, revert to previous versions, experiment freely, collaborate with others without that fear of losing your work.
Exactly.
They even advocate for using version control, even for personal projects, not just for team projects.
It's a great habit.
Absolutely. It provides a history of your work, helps you recover from mistakes, and it makes it easier to collaborate, if the need arises.
It does.
So version control is all about security, flexibility, and collaboration.
What about debugging? I feel like that's a skill that every programmer needs to master.
Debugging, it's an art and a
Huh?
science, and the book offers a bunch of practical strategies.
So what are some key techniques they recommend?
Well, they emphasize reproducing the bug reliably so you can understand its behavior.
Then use techniques like binary search. Isolate the problem. Challenge your assumptions. Use debugging tools to gain visibility.
Binary search for debugging. How does that work?
It's a divide and conquer approach.
Okay.
Instead of going line by line, you eliminate large chunks of code until you narrow down that problem area.
It could be incredibly efficient, especially for large code bases.
It can.
And what about challenging assumptions?
Well, they highlight the element of surprise in debugging. When you encounter a bug that seems impossible, it's often because one of your assumptions is wrong.
So it's about questioning those deeply held beliefs about how the code should work.
Exactly. Be open to the possibility that your understanding is flawed, and be willing to dig deeper.
To uncover the truth,
It's like being a detective
looking for clues.
and following the evidence.
And sometimes you need the right tools to help you with that investigation.
Absolute.
And that brings us to text manipulation.
Text manipulation.
What's the idea behind that?
Pragmatic programmers, they're fluent in manipulating text.
Okay.
They use tools like regular expressions, scripting languages, specialized text editors to automate tasks, transform data, gain insights from their code.
So it's about treating text like as a raw material.
Yeah.
They could be shaped and molded.
Precisely. And to further aid your memory, they suggest keeping an engineering daybook.
An engineering daybook. That sounds kind of old school in this digital age.
You might be surprised.
What is it?
It's a place to jot down your ideas, record your decisions, track your progress, reflect on your experiences.
So it's like a journal for your coding journey.
It is capturing those aha moments and the evolution of your thinking.
And it's a valuable resource, I imagine, for looking back.
It is.
Learning from your past experiences.
Seeing how your skills have developed over time.
It sounds like a great way to improve self-awareness.
It is.
Track your growth as a programmer.
Absolutely.
Now let's move on to a concept that sounds a bit more formal. Design by contract.
Design by contract.
Or DBC. It's a powerful technique
Right.
for building robust and predictable software. It's about defining clear agreements between different parts of your code.
Like having a contract.
Yeah.
What each piece of code is supposed to do.
What conditions need to be met for it to function correctly.
Exactly.
So it's not just about writing code that works. It's about writing code that's designed to work predictably and to fail gracefully when things go wrong.
Exactly. Establishing that level of trust and predictability in your code, each function, each method, it has a contract. It specifies the preconditions, the postconditions, and the invariants.
Okay, remind me again, what are those? Preconditions, postconditions, invariants.
Preconditions are the things that must be true before a function can be called. Postconditions are the things that the function guarantees will be true after it completes.
Okay.
And invariants are conditions that must always hold true for a particular object or module.
So it's like setting clear expectations guarantees.
Right, for different parts of the system, how they interact.
Right. It's about defining those boundaries of each component, making sure those boundaries are respected.
Precisely.
And how does this help in practice?
Well, for one, it helps you catch errors early on. If a precondition is violated, you know there's a problem in the calling code.
It's like a built-in safety net
It is.
that alerts you to potential problems.
It forces you to think defensively, anticipate those potential problems, put safeguards in place.
It's about designing for failure.
Yes. Making sure your code can handle those unexpected situations gracefully.
And speaking of failing gracefully, they advocate for the somewhat controversial strategy of crashing early.
Crashing early.
Isn't it better to try to, recover from errors, keep the program running?
Sometimes crashing is the best option. Prevents the program from continuing in an undefined state,
Oh, okay.
potentially corrupting data
Yeah, that's bad.
or causing further damage.
It's like hitting the emergency brake
It is.
when you realize you're headed for disaster.
It might be a sudden stop.
Yeah.
Better than careening out of control.
Much better.
Trying to limp along in an undefined state, it can lead to subtle bugs, inconsistencies, much harder to track down. It's better to fail fast, fail visibly, than to slowly decay into a mess.
It's a bold approach, but it makes sense.
It does.
Sometimes a clean break is the best way to ensure that data integrity
Right.
prevent further damage.
Absolutely.
And they highlight the importance of using assertions. Those little checks we put in our code to make sure things are, as we expect.
Those are like canaries in the coal mine.
If an assertion fails, it means something is fundamentally wrong.
You need to address it immediately.
It's a way of enforcing those assumptions that are crucial for the correct operation of your code. It's about building in those early warning systems.
That can prevent small problems from becoming big disasters.
Exactly. Now, Chapter 20, it tackles the challenges of juggling the real world.
Juggling the real world.
Building applications that interact with external systems. Handling asynchronous operations. Responding to events. In a timely and predictable manner.
That's the real world.
It is. It's a reality for most, for most software developers. We're not just writing code in a vacuum.
We're not.
We're building systems that need to interact with users, with databases, APIs, all sorts of external factors.
Absolutely.
They start by emphasizing the importance of decoupling, which we touched upon earlier.
We did.
It's about minimizing dependencies between different parts of your code, making your system more flexible, adaptable to change.
Like building a system with modular components.
Yeah.
That can be easily swapped, replaced, without affecting the rest of the system.
They warn against train wrecks, those long chains of method calls.
Yeah.
That make it, they make it difficult to understand the flow of data, the flow of control.
They do.
So it's about breaking down those complex interactions.
Yeah.
Into smaller, more manageable pieces.
It makes your code easier to read, understand, maintain.
They also caution against the dangers of global data and excessive inheritance, both of which can lead to, to tight coupling and fragile code.
They can.
Global data is like a ticking time bomb.
It is.
It can create hidden dependencies, make it difficult to reason about the state of your program.
It can.
And excessive inheritance can create like a tangled web of dependencies, making it difficult to make changes without those unintended consequences.
It does.
They advocate for using techniques like events and reactive programming to build those more responsive and decoupled systems.
They're powerful tools for managing asynchronous interactions, creating systems that respond to events in a timely and predictable manner.
So it's about designing systems that are more like choreographed dances with different parts, moving gracefully in sync, rather than like a tangled mess of spaghetti code.
Precisely.
Now, this next concept is a bit mind-bending. Transforming programming.
Transforming programming.
It's about shifting our thinking from a code-centric approach to a more data-centric one.
Interesting.
So it's about seeing programs as like pipelines that transform inputs into outputs.
Yeah.
Instead of focusing on classes and objects, we focus on that flow of data through the system.
I see.
It's a different way of thinking about software design, but it can be very powerful, especially for tasks that involve like processing and transforming data.
It can.
They introduce the concept of pipelines, which is about composing those transformations into a clear and readable sequence.
Like assembling a series of data processing steps.
Each with a specific purpose.
It makes your code more modular, easier to understand.
And they emphasize that this data-centric approach can lead to more testable and reusable code.
Absolutely.
It's a powerful paradigm shift.
It is.
That can change the way you approach software design.
It can.
And this concept of data flow, it ties nicely into their discussion of concurrency.
Yeah.
And breaking temporal coupling.
Concurrency, it's all about doing multiple things at the same time.
At the same time.
And temporal coupling, it's when your code imposes a specific order of operations. That's not truly required.
So it's about removing those unnecessary constraints, allowing things to happen in parallel when possible.
Exactly. It can significantly improve performance, especially in today's world of, multi-core processors.
Makes sense.
To give a great example, fetching data from multiple web services, instead of fetching them one after the other, you can fetch them concurrently.
Okay, yeah.
Significantly reducing that overall execution time.
It's like having multiple chefs working in the kitchen.
Exactly. Each chef focuses on their task, and the meal gets prepared much faster.
Much faster.
They introduce different concurrency models, actors, processes, blackboards, each with its own strengths and weaknesses.
So it's about choosing the right tool for the job, understanding the trade-offs, designing your system to handle concurrency safely and effectively. Concurrency can be a powerful tool, but it also introduces new challenges.
Yeah.
Especially when dealing with shared state.
It does.
That's why they dedicate a whole section to the perils of shared state and the importance of using techniques like immutable data structures, message passing, to avoid those common concurrency pitfalls. Shared state can lead to race conditions, deadlocks, all sorts of nasty concurrency bugs.
It's notoriously difficult to debug.
They are. It's like having multiple people trying to edit the same document.
Yeah.
at the same time.
Overwriting each other's changes.
It's a recipe for disaster.
It is.
By using, immutable data structures in message passing,
Yeah.
you can avoid those situations and make your concurrent code much more reliable.
You can.
This has been a lot to take in.
It has.
It's amazing how the pragmatic programmer covers such a wide range of topics,
Yeah.
from like the philosophical to the technical.
It's a testament to the depth and breadth of this book.
It is, and we're just getting started. Join us next time as we continue our deep dive into the Pragmatic Programmer, where we'll explore even more advanced techniques and strategies for building better software.
Looking forward to it. Back again for more Pragmatic Programmer wisdom.
That's right. Last time we laid the groundwork, taking ownership, adopting those key design principles. But today, well, we're digging deeper into some of the more, I guess, nuanced aspects of pragmatic programming.
Nuances. Always important, right?
Absolutely. And one that really stood out to me, the concept of building your knowledge portfolio.